Hello, I'm Nicole Cesaraga and we'll be discussing about transport layer and application layer. So first, I'll discuss transport layer. So what is transport layer? This provides a reliable mechanism for exchange of data between two computers. It's the fourth layer of OSI stack model and it has two types. First type is transmission control protocol or TCP, then user diagram protocol or UDP. Now, transmission control protocol. It is connection-oriented transport layer of the internet. So what does connection-oriented means? Connection-oriented means that enable to connect two stations or two ports, a connection should be established first, just like in the telephone. There should be a telephone wire connecting to the outer part so that your call would get through to the destination or designated phone you're calling. So it aims to provide end-to-end byte stream between two hosts. So how does data transfer happen? So here are some diagrams. So from the top layer sends data, then that data will be controlled by the transport layer. Then the transport layer sends the data to the lower layer, where the lower layer of our OSI stack connects or communicates with the other lower layer of the OSI stack of another computer. So when the data is received by the other computer, the lower layer of that other computer sends the data to the transport layer, then sends to the top layer. So TCP has 16 bit-wide ports. Then that equates to 0 to 65,535 ports. But the 255 and below ports uses or are reserved for special functions for our computer. Here are some of the special functions of those port numbers. So port number 20 is for FTP data, so file transfer protocol data. 21 is for FTP or file transfer protocol control. 23 is for the telnet. 25 is for the SMTP or simple mail transfer protocol. 42 is for the name serve or host name server. 53 is for the domain name server. So how does TCP moves into action? So here's a sample diagram or communication between two computers. First computer has an IP address of 192.168.1.23. Then the second computer has an IP address of 192.168.1.54. So when the first computer sends data to the second computer, how does the second computer handle that data? An example is maybe in your browser. You type a website. The server where the website is being hosted sends data to the computer you're using. So how does your computer you're using connects the data to the web browser? That's where TCP or transfer control protocol happens. So on that data, there's a specified TCP port. An example here is the port number 22. So once our computer receives the data, it immediately knows where or what application needs that data. So an example is port 22. So let's say this is the web browser. So the computer then sends the data to our web browser. So here are some of the characteristics of TCP. So full duplex and point-to-point. So full duplex means that the data can transfer or can travel both ways. So in the channel, data can travel from and to at the same time. Then it is point to point. So in the connection or the transmission process, every destination has a specific source. Now here is a sample header of a TCP. As you can see, there's the source port, then destination port. As we discussed earlier, a source computer has an application. So that application, let's say port 22, sends the data to the computer, then the computer specifies it in the header of the data frame going to the destination computer, which also has a destination port, which is, let's say, port 23. So in this way, TCP helps that the application with port 22 of the other computer would communicate or send data to the application with the port 23 of the other computer. Now let's go to the function calls. So what are function calls? Function calls are instructions on what TCP should do. Some examples are open, close, send, receive. Open means it is open for communication. Close, it is close to communication. Send is sending data. Then receive is a function call for receiving data. So open function call. There are two types, active open and passive open. Active open is a way of TCP to request a connection. Passive open is TCP is expecting a connection. So now here we have two clients, client A and client B. So client A is in active open, then the server is in passive open. So this means that client A is requesting a connection between the server. Then the server is now passive open and is expecting a connection. So how does this connection happen, or how does this connection is established? So here is how the connection is established between client A and the server. So first, client A sends a data packet or data frame with the sequence number 200. Then the server now sends a data packet or data frame to the client's computer with acknowledgement 201 and a sequence 550. So when the client receives the data packet, it knows that it is what he is expecting. Since the sequence number here, the client's computer sent as a sequence number 200, then he knows that this is the correct data he is receiving because he's expecting an acknowledgement of 201. Then the client A sends a data frame or data packet with the sequence number 201, which is the acknowledgement that he or the computer receives, then send another acknowledgement with 5501, since this is the acknowledgement that the server is expecting, since it sent a sequence number 550, I mean. So this is how, so once this happened, a connection now is established. This is what we call three-hand three-way handshake, where this should first happen to the connection before a more concrete connection is established. So now let's go to User Datagram Protocol, or UDP. UDP is a connectionless transport layer protocol. So what does connectionless means? So connectionless means that the data is being broadcasted to the network where it doesn't guarantee that the data arrive the destination. So it has some functions, it has the same functions as TCP. They identify the endpoints, the source, and destination machines. But, as I said, it doesn't guarantee that the data from the source arrived at the destination because it's connectionless. So this is why it doesn't provide sequence numbers and acknowledgement, and doesn't guarantee the packet arrives or received. So let's now move to application layer. So what is application layer? It's the most obvious from the end users. Perform actions directly from the users. So some of the example are web browser. So this is the most obvious because the end users can see a web browser. Then performs action directly from the users because we are typing our URL to the web browser. Then we scroll to the web pages that we see. Then some others are clicking or closing tabs. But here are some of the applications in our computers. So DNS, Telnet, www or World Wide Web, file transfer, and email. So now let's first go to the DNS. A DNS is like this, or the URL, www.facebook.com. So what does this part means? What does Facebook mean? .com means. So let's go to the .com. .com is the root, or how the DNS or URL is categorized. So we have the country, .gov, .edu, .com, .mil, .org, .net, and ARPA. So country is for specific countries, government is for government, education, and organization for .org. So here are some of the top level domains. It's .com for commercial entity, government for government, edu for educational institution, org for organization, .net for network providers. So that separates the components of the DNS. It's case sensitive, up to 63 characters long, and allows domain names up to the second. An example is the websites that have URL that have .jp.edu or .edu.jp or uplb.ph.edu.ph. So how does the DNS work? So actually, our URLs are not exactly what I could say name friendly, just like www.facebook.com. Actually, that's just a mask or a front face of our URL. Actually, the real meaning of there's a IP on the back of that. Sample is here in our client. When it requests it type a URL to the browser, it requests a connection with the server where the URL is being hosted. So let's say we type www.facebook.com, then that first goes to the name resolver or name server, which interprets the URL, which is facebook.com. Then the name server sends the IP address of the server that's hosting the URL, which let's say like this 192.168.0.1. Then the name server send that IP to the client's computer. Then the client's computer now establishes connection with the server, which is hosting the URL that we type, or the client type, to the web browser. So that's in that way a connection is established between the client and the server. So next is the telnet. Telnet performs remote terminal services, wide area network based on CCITTX25, runs over TCP/IP. So here are some of the requests or types of communication in telnet, which is will then option, response do or don't option. Do option will respond has a response of will and won't option. Now let's go to file transfer protocol. This allows files transfer from a host to another, reliable file transfer, and uses port 20 to control connection and 20 for data transfer. So what does file transfer protocol means or applied to the current world? So it is, have you imagined sending, let's say, 1 gig of data from your computer to your friend's computer? You can send that to email, or you can send, maybe you can copy that to a USB, then send that USB to your friend so that he or she can copy the file to his or her computer. But one way is file transfer protocol. It allows to send big data from a computer to another computer. So here are some of the commands for file transfer protocol. Open, which initializes connection to a remote site. Closes current connection. By for terminates the FTP session. Binary indicates the file to be transferred in a binary type. Then get fetches a file from the remote station. Now let's move to the www or World Wide Web. So what is World Wide Web? World Wide Web is used to access distributed but linked documents in the internet. Started as a small hypertext system used by the engineers at CERN, web consists of documents called pages. Pages may contain photos, text, graphs, and links. And links are denoted by URL or Uniform Resource Locator. Pages can be viewed using web browsers. So basically, World Wide Web is the thing or the whole system that we saw in our browsers, where we could browse or we click link going to different pages or type the specific URL for different pages that is available on the internet, or as we call the web. Now let's discuss about Uniform Resource Locator or the URL. So this gives a web page a unique worldwide name, and it has 3 parts: the protocol, DNS, and file name. So as you can see, this is the I could say this is what we usually type on the input part of our web browser. So an example is www.facebook.com/nicolezaraga.html. So what are this part mean? So the protocol is the HTTPS or Hypertext Transfer Protocol safe. The domain name is www.facebook.com. Then the path or file name is nicolezaraga /.html. So now let's move to hypertext markup language. So what is hypertext markup language? This is a language used how to display or format a web page. So on the side note, have you ever wondered what's the manner on how the different companies or developers on how they format, or what are they using to show the web pages that we browse? So the basic building block of the HTML are the tags. And actually, all the HTML pages are full of tags. And some of the examples of the tags are HTML, body, and A is for the links. So each HTML tags has the opening mark, which is, as you can see, the HTML, then the closing, which is /HTML. So how can you imagine how different web pages are designed? So as you can see, if you can open a browser, then type any URL, then if you right click the page, then click inspect, there will be a panel that would open on the right or on the bottom of the browser. As you can see there are a lot of tags. This is how a web page is built. So this is the building block of every web pages that we can see. So now let's go to the electronic mail or email. I think at the time around 2000, middle 2000, this is very hit between the people living on that time, because email is very magical or something like that, because you can communicate with other people on the far side of the earth without the conventional fees like long distance call or any other like that. So what is electronic mail? It is a system where a computer can communicate with another computer using a communication network such as the internet. It has two subtypes, the user agent and the message transfer agent. So what is user agent? It allows people to send, read, save, and retrieve mail. Message transfer agent, the meanwhile, moves the message from the sender to the destination. So there are 5 basic operations of an email system. One is composition. This is where an email is created or answered. So this is where we start opening the editor of the email, where we type the message and the sender, or where we want to send the email. So transfer is moving. The second one is transfer, or moving the message by establishing a connection, outputting and releasing connection. The third is reporting. Identifies the possible status of the message. It's either lost, delivered, or rejected. Then displaying is the process of showing email message to the screen. Then the last is disposition, the process of saving, forwarding, and discarding a message. So that is the last topics of our chapter. So thank you for listening, and once again, this is Nicole C. Zaraga, and here are my references.